Test. Yep, now we're working. All right, tangent and cotangent. Unit circle, out, please. X tangent of x, okay? When x is 0, what's the tangent at 0? What's the tangent at 0? Tangent is y over x, right? So it's 0 over 1, which is 0. Then let's go to pi over, let's just go pi over 4. It'll be easier that way. Pi over 4, what's tangent? 1. Pi over 2, what's the tangent? What's 1 divided by 0? Undefined. 3 pi over 4, what's the tangent? -1. Pi, what's the tangent? 0. 5 pi over 4. 1. 3 pi over 2. Undefined. 7 pi over 4. -1. 2 pi. 0. And we keep repeating. So what does the tangent function look like? Well, it looks like this. So at 0, we're at 0. At pi over 4, we're at 1. Pi over 2, it's undefined. When you're undefined, you have an asymptote there. At 3 pi over 4, we're -1. Pi, we're 0. 3 pi over 4, we're 1. And 5 pi over 4, we're 1. Then we're undefined at 3 pi over 2 again. So another asymptote. -1, 0. So if I go in a pattern, I bet I'm here, and then I bet I have another asymptote here. So what's it going to look like? Well, it's going to go along this asymptote till it gets to here. And it's going to go through here. It's going to go up like this, along this asymptote. That's a tangent curve. Now, I could go like this if I wanted. I could put another asymptote, 1, 2, 3, 4, back over here. And go here, and then go here if I wanted. But I'd like 2 asymptote curves in there, please. 2 curves of the asymptote. Okay, when you do it. So, was that very hard? No, it wasn't that hard. So, we ready to do cotangent now? Sure, let's do cotangent. So, x and cotangent of x. Okay, again, 0. What's cotangent at 0? Well, it would be x over y, right? What's 1 divided by 0? Undefined. Pi over 4. 1. Pi over 2. 0. 3 pi over 4. -1. Pi undefined, not 0, undefined. 5 pi over 4, 1. 3 pi over 2, 0. 7 pi over 4, negative 1. And back to 2 pi, undefined again. Okay, so when we do cotangent, we have an asymptote right on the y-axis because that's 0. We have an asymptote. At pi, we have an asymptote. At 2 pi, we have an asymptote. So then at pi over 4, which is halfway in between 0 and pi over 2, pi over 4, we're at 1. Pi over 2, we're at 0. 3 pi over 4, we're negative 1. 1, 0, negative 1. Okay, so looking at these, what's one similarity between tangent and cotangent? One similarity. They have the same style of curve, yeah? Okay, I'll take that. What's another similarity? They both have asymptotes. They both have asymptotes. Differences. What's the difference between this one and this one? Yep, one has a positive slope, the other one has a negative slope. Okay, they're reflected over the x-axis. What's another difference? Like where the asymptotes are. Yeah, the asymptotes are basically pi over 2 away from each other, right? Okay. One has them at pi over 2, 5 pi, 3 pi over 2, 5 pi over 2, 7 pi over 2, all the over 2s. The other one has asymptotes at 0, pi, 2 pi. Okay? Now, when we have y equals tangent of x minus pi over 4 plus 1, if we have something like this assigned to us, we're not going to make the tangent of x minus pi over 4, and the tangent of x minus pi over 4 plus 1. We're not going to make 3 graphs. We're going to make 1 graph in the end. But we're going to make a really complicated XY chart to graph them. Okay? So here we go. So we've got an x. We've got our x values that we're going to put down. And then we've got our tangent of x values that we're going to put down. Okay? Just like we did originally. So at 0, what's the tangent at 0? We said it was 0. Pi over 2 was 1. 3, or pi over 4 was 1. Sorry, my bad. Pi over 4 was 1. Pi over 2 was undefined. 3 pi over 4 was negative 1. Pi was 0. 5 pi over 4, 1. 3 pi over 2 was undefined. Seven pi over 4 was -1. 2 pi was 0, and so on. Okay. Now, what does this do to the graph? Moves it to the right, pi over 4, to the right. So if it moves it to the right, pi over 4, does it affect the x or the y? Because this is the x, this is the y. It affects the x. It affects the x. So what we're going to do is make a column here that says x minus pi over 4. What we're going to do to it is just take these and subtract pi over 4 to them. Okay? So it's going to be, now let me think. Everything moves to the right, pi over 4. So we're going to add pi over 4. Even though it says x minus pi over 4, we're going to add pi over 4. So this becomes pi over 4. Pi over 4 becomes 0. Yeah. So this becomes pi over 4. This becomes pi over 2. This becomes 3 pi over 4. This becomes pi. This becomes 5 pi over 4. This becomes 3 pi over 2. 7 pi over 4. 2 pi. And then 9 pi over 4. Then we're going to have a tangent of x plus 1, right? So how is that going to move it? It moves the y up 1. So we'll take each of these numbers and go 1, 2. Undefined plus 1 is still undefined. 0, 1, 2, undefined. 0, 1. Okay. So then graphing this. We do not graph either of these two columns because we have two new columns. This is a new x column. This is a new y column. If you only change an x, then you graph your x and what your original y was. Well, let's undo here because I didn't know I made those things disappear. So x and y. Okay. So we're going to just graph these. So I am going to graph pi over 4, which is right there, 1. And then pi over 2, 2. 3 pi over 4, undefined. Pi, 0. 3 pi over 4, 1. Or 5 pi over 4, 1. 3 pi over 2, 0. 2. Asymptote. Same pattern over here. Okay? Tangent with something involved. Okay? Y equals -2 cotangent 2x. Y equals -2 cotangent of 2x. All right. So we are going to first go what's x and what is cotangent of x. So we start at 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. So we start out with an undefined here, here, and here. Pi over 4 I know is 1. Then we go to 0. Then we go -1. 1, 0, -1. The -2 out front, what does it affect? The x or the y? The y. So this affects the y. So the -2 is what I'm really worried about there, not the cotangent 2x. So the cotangent 2x, what does it affect? So what does the 2x do to the x? Makes it twice as skinny. So we're at a 0. Instead of being at pi over 4, we're pi over 8. Because that's twice as skinny as pi over 4. Instead of being at pi over 2, we're pi over 4. Instead of being at 3 pi over 4, we're actually 3 pi over 8. We're multiplying each of these fractions by 1/2. Okay? So this affected our x, made our x skinnier. Now, what does that -2 do to my y? Multiplies it by -2. So it flips over the graph. You're multiplying each of those by -2. Well, what's undefined by -2? Still undefined. What's 1 times -2? What's 0 times -2? What's -1 times -2? Just imagine if we were graphing everything on here. We'd have so many asymptote lines down there, it would be very confusing. That's why we only graph what we have at the very end, okay? That's why we write out the charts and we're just graphing this stuff right here. Okay? So, if this is pi and this is 2 pi, then this is pi over 8, 3 pi over 8, and so on. Okay? So at 0, we're undefined, so we have an asymptote. Let me put my asymptotes in highlighter here. So we have an asymptote right there at 0. We're going to have an asymptote at pi over 2. We're going to have an asymptote at pi. At pi over 8, which is, this is pi over 4, so pi over 8 is right here. I'm going to be down at negative 2. At pi over 4, I'm going to be at 0. At 3 pi over 8, I'm going to be at 2. It's a very skinny graph. Looks like that. How's that for you? Can you handle doing tangents? We're only doing one, we're not graphing graphs on top of each other. We're figuring out where the points are and then going from there. Let's do 34, 37, and 39 only. You got 25 minutes to work on them and get those 3 done. And then we will talk a little bit, and then you'll get a practice test. Oh, I got to give you a page number. Page 144.